Yeah. Thank you.
See, I'm trying to mitigate risks before they happen. So thank you very much for having me here today. And this talk is going to be on risk-based project management. And I think it's a very appropriate talk in line with some of the other speakers talking about resiliency. One of the major ways you can deal with, I think, resiliency issues and understanding the future, which is unknowable, is to think about the risks that can occur. So hopefully you'll find this presentation interesting. I welcome your feedback and questions. So with that, just a bit of background about me, the least important thing about this talk, really. I've been working in the IT industry for 25 years. I actually used to work for a company called Sapient in Boston, working in IT there. And then I've been the founder and CEO of Inflectra for about the last 15 years. We produce software to help with project management, risk management, and testing. I live in Washington, DC. And if you want to reach out to me, you can see my Twitter handle and LinkedIn. Feel free to contact me there. Happy to chat more. So today I'd like to talk about risk management and agile and software projects and how we bring risks into those, but also how we can bring risks into other aspects of the IT lifecycle, whether that might be hardware, it might be also in the software testing sphere. I also want to touch on a little bit about how AI and machine learning is changing the discipline of risk management. And then I'll take questions. So it's going to be covering a lot of different angles of risk management. And I'm going to not assume that you have a strong knowledge of agile or risk management, so there will be some background pieces as well. So if you're familiar with those topics, don't worry, we will be getting to the meat of the presentation, but I want to make sure that I bring everyone up to the same level to start with. So first of all, a little bit of background. First about Agile. So many of you may be working in the software industry, you're very familiar with Agile, but just to get everyone up to speed, when I was working at Sapient back in the late 90s, we didn't have Agile. What we would do is we would meet with clients, we would gather requirements, we would talk a lot about them, we would do workshops, we would write them down on lots of paper, we call those requirements documents, we would then spend some time thinking about the problem, designing it technically, we'd build it, we then try and test it, and then we'd have the users look at it, test it, and we release it. Seems pretty good. But unfortunately, there were some problems with that, which we're going to get into later on, and particularly around the idea that users, by the time you got to the end of the project, which could be 6 months to 9 months, it might be late, it might not be what the user actually wanted, and a competitor might have released something before you even released it. So I think they said at the time 2/3 of all software projects failed. The Standish report that at least 2/3 of all projects fail either because they're over budget or they're cancelled completely or they're late. So because of that, the Agile methodology came along, and the idea was you break a project down into smaller pieces that we call releases and iterations or sprints, and we're releasing much more continually. It's much more adaptive. So in many ways, it's an adaptive process where as you learn, you change, as opposed to a prescriptive process where you think about things, prescribe it, follow a process, and deliver it at the end. And there's lots of controversy in the industry about whether it's better or worse. Some people would say that we've lost something in going to Agile around requirements, and that's another talk we can have. But in general, Agile has improved things. It's allowed us to release software faster and more safely and with the higher quality and in a way that allows us to adapt to change. So back to resilience, if you're thinking about resilience and you're thinking about the world is unknowable, you want a process that allows you to change. So that's a very high level of Agile. There's a lot more to it than that, but just to give you a little bit of background. Now, one thing that Agile has then led on to is the idea of continuous delivery, which is the idea of DevOps. You may have heard this, development operations. What Agile said was we can build software faster. And what DevOps or continuous delivery does is you can now actually develop it not only faster, but we can deploy it faster. So the fact that when you log into Gmail, you may have an update that happened yesterday, you may have from a week before. You go to Facebook or any modern consumer application, especially, it's updated all the time. It's not like a once a month release or once a year release. For the most part, they're deploying all the time continuously. Google's algorithms are changing almost overnight. Business applications and the IT industry as a whole is moving in that direction. So we're moving away from fixed releases every 6 months to much more continuous updates as users need things, as features need to be released, as we get feedback from customers and users. So Agile kind of was the first part of the revolution. Continuous delivery is the second part. So that's DevOps and continuous delivery. Hold that for now. We're now going to talk about risk management, which is really the focus of this talk, but you'll see why we talk about Agile before. So what is risk management? Well, when I thought of risk management, people in the project management or software industry often think of risk. Yay, let's play risk. But that's not really what risk management is, much as that will be fun. Risk management is more like this. So we got a data center, and it's serving thousands of customers, hundreds of thousands of customers and users. I'm an IT manager. Everything's running nicely. I've got everything delivering value to customers all the time. And then this happens, something unexpected. We don't know what it could be. If you look at the news, there's data outages, there's someone pushes the wrong piece of code into production, someone unplugs the wrong thing, there's a power failure, there's electricity shortages, there's a DNS issue. I mean, you've heard of so many times where systems go down, something happens unexpected, and as an IT manager or a project manager, you have to think of these things. And really, that's what risk management is about. Risks are the things that haven't happened yet. So if you work in project management, you're often thinking of things that have happened. You're thinking of features, requirements, user stories. You're thinking of tasks. You're thinking of things, issues or incidents, things that have happened already. Oh, we've got a new bug in this product. We need to fix it. Or it might be a business issue. Oh, this application doesn't work the way we expect it to. These are all the things that have happened. So in project management, there's a huge focus on dealing with issues, dealing with requirements, dealing with user stories, dealing with tasks, dealing with work breakdown. But risk is something that I think has often been forgotten, especially in project management, maybe a little bit less so in IT management and PMOs, program management. I think risks have been more integral, but risks are not typically well integrated into the project management discipline, or haven't been, certainly in a lot of software projects that I've been involved with. So risks are things that might happen in the future, unlike an issue which is happening now. And actually, in theory, risks can be both positive, as it says here, winning the lottery, but risks that we really worry about are the ones that are negative. Something that could happen in the future, like I mentioned, there could be a power cut, the data center could go offline. There could be someone could inadvertently cut through one of the network cables that connects that data center to the internet. These things have happened. Someone pushes a piece of code into production that shouldn't have been. Someone inadvertently turns off the authentication system for security, and no one can get into the system. These have all happened in real life. These are all risks that can happen. They're all negative. And the question is, how do we deal with them? How do we think about them? And how do we plan for them? So one of the things that you would do, I recommend you do, is first of all, think about risks. Have an actual identification session with your teams. Go down into a virtual or in-person workshop and force everyone to think of all the risks. It's actually a hard exercise. People like to think of the things that are very likely, but they don't want to look stupid. So they don't want to look at, oh my goodness, there could be someone cutting the cable with a backhoe loader. That'll never happen. So one of the things we find is helpful is take away the stigma out of it. Use the free approach called what's the least craziest idea or the least worst idea. We've done that in our company, and it really helps people to come up with innovative things that may be edge conditions that actually do happen or could happen. So basically, think of every possible thing that could go wrong with a system, a project. Could be a software project, could be a physical piece of infrastructure, could be a data migration project, could be an upgrade of a system, could be moving to the cloud. Whatever it is the project you're working on, think about all the possible things that could go wrong with it and build a tree, basically decomposing from the high-level themes. Here you can see we've got time, people, technology. Those are just some examples. There could be financial risks. Break down the risks into this hierarchy of ideas, and that will force you to actually consider all the possible risks. Because if you have these 10 major buckets and you're breaking it down, people will naturally want to fill out each bucket. So it forces people getting overly obsessed on, say, technical risks and ignoring people risks, because that's often the problem, is that people like to focus on one area and forget the rest. So now you've got your risks and you've identified them, which is great. What do you do with them? Well, you need to quantify what we say, how bad are the risks? And people will say, is this a bad risk? Well, there's not really good or bad. The question is, how likely is it? So that's the first thing. One of the things we want to understand is, how likely is this risk? Because there are risks that may be actually not particularly dangerous, but they're very likely to happen. And there could be risks that if they happen, may be catastrophic, but they're very unlikely. So the first measure that needs to be measured independently, though, is how likely is it? How likely is lightning going to hit a data center? It's pretty unlikely. It's rare. How likely is it that someone's going to push a piece of code into production that's wrong? Depending on your process, that's possible. How likely is it that a drive on a machine in a data center is going to fail? If it's a magnetic drive, it's actually very likely, probably certain, in the next 2 years, that's just the lifespan of a drive. And so everything has that continuum. How likely is it? And the first thing to do is go to every risk you've identified in that matrix and rate it just for probability. Don't think of how bad it is, just probability. Next, do the same exercise, but do it only by how serious it is. Don't worry if it's likely or not. It may be once in a blue moon, but is it bad? If lightning hits your data center, though it is very unlikely, is it catastrophic? Is it not? Is it shielded? Is it basically going to be marginal? You'll know. You can do an assessment of that. So figure out how dangerous the risk is. Now, once you've done those independently, and it's important to do it independently because what you want to avoid is people second guessing this exercise. Once you put them together, though, you now put them into this matrix that we call a risk cube. And that's where you take all the risk impacts, all the probabilities, and they've got a number 1 to 5, multiply them together, and the highest number will be a very likely risk that has a high degree of impact. Those are the ones you should worry about. And there might be some very rare risks that, if they happened, will be marginal anyway, that you probably don't need to worry so much about. And that's why the risk cube is really useful. Things to the top right in this version of it would be bad. Things in the bottom left would be less. We wouldn't need to focus that much on. Now, one of the challenges I would say with this is that people often focus on that top right quadrant in its isolation. That's the certain and catastrophic. Be careful with that because everyone was worries about the things that are very likely and very bad, but the things that are fairly likely but bad, like the catastrophic, that whole row of catastrophic, particularly the possible and likely columns and the critical possible and likely, any of that basically top 3 by 3 in the top right, you should worry about all of those because it's the ones that are possible and critical. They're the ones that you might miss because the chances are it could happen, which is quite likely actually. And if it does, it's still critical. So don't just focus on the top right, focus on the squares in that approximate area. So that's just one thing I would say. So now you've got a sense of all the risks you've identified in a systematic way, where are you most exposed? And we call this the exposure. So that's the multiplication of those two independent values. Now the question is, how do we reduce those? Well, we should try and reduce those. If we know that the lightning is going to hit a data center, we could do things to shield it. If we knew that drivers are going to fail, we'll use RAID drives. If we know that a data center could be disconnected from the internet, we'll have 2 data centers. There's lots of things we can do. And those are called mitigations. And so mitigation is an action we can do, and it can do one of 2 things or both. It can either reduce the probability or it can reduce the impact. And sometimes it can do both, but not always. So for example, if we have another data center, we're not saying it's less likely that we're going to have someone cut through a cable to the internet. We're just saying its impact is marginal instead of critical because we have a whole other data center. Data is all replicated in real time. Doesn't matter that much. The DNS will fall over within seconds. Users won't even notice. The second option would be, we can't do that very easily. We're going to shield the data center with lots of Faraday cages, so lightning won't hit it. It's actually almost impossible. So the impact is still pretty bad. We've just reduced the probability. So you can decide to reduce one or the other, and in many cases you want to try and reduce both, because just in case the mitigation doesn't work, not all mitigations are going to work. So these are actions you take to reduce your exposure. And in this example, you'll see we've reduced the exposure from 12 to 6, which is great. So just to recap, we got our risks. These are things that could happen. We understand the severity and likelihood of them, and we now try to reduce them. And one of the things we often do then is think about how do we make our projects adapt to this. So as I mentioned a few minutes ago, risk management has unfortunately been often seen as the purveyor of a different team, or the risk guys. They're going to do the risk assessments in their own ivory tower, and they're going to come back with some giant spreadsheet of risks. What I think is really important is we need to start thinking about how do we integrate risks and risk thinking into the project plan, to the scrum master, to the product owner, to the program manager, whatever level you're managing these IT initiatives. Make sure it's integrated. So do things like, when you define all these risks and you have mitigations, well, that's work for someone. Maybe you can take those risks, break them into tasks, so each mitigation becomes an action. That action belongs in the team. The team should be doing that. If a technical person is doing the architecture, maybe they could factor that in. Whoever's designing the data center or the network topology, these risks should be factored right into that plan. It shouldn't be done in a separate group. If you're defining requirements and user stories and other methods of understanding the functionality, make sure those risks are factored into that. And then lastly, when we get into the idea of software testing or hardware testing or system testing, testing is a great way to actually measure risks, because you could test the data center. You could see what happens if lightning does hit it, simulate it. You could simulate removing drives. You could simulate unplugging the network. There are ways you can test things. So if you're doing testing, those tests should be integrated into the risk with the risk plan. So the risk management and the testing, the risk management and the project management, the risk management and the development are all together. They're not separate disciplines. And in fact, if you look at Netflix, they've done this thing that's called chaos engineering, which is quite famous now, where rather than trying to do all this testing, they just unplug things. So they actually unplug randomly systems every day, and they make sure that everything is resilient. So the idea of resiliency done through risks and testing. And so it's a way to keep the technical people on their toes. And so that way it forces them to actually build this into their designs. Someone's going to unplug this. What happens? Let's build for it. It's a bit extreme, but it is becoming more mainstream. So when we talk about software projects, though, so these are software projects where we're designing a system, building a system, implementing software in some fashion. It could be custom development. It could be like an ERP implementation, anything where we're releasing software. There are actually three major types of risk that we should focus on. The first one is the conceptual risk. And I mentioned earlier on about Agile, and we'll come back to that. One of the biggest problems that we found when developing software is that the idea of the requirements as written down don't match what the user thought, or what the user thought isn't what their industry or customers need. And so building the right thing is actually very hard. So the conceptual risk is a very difficult risk to deal with and mitigate, but it's critically important. Is this thing we're doing going to actually work? Is it the right thing for our customers? Is this business even viable if it's a startup? And there's a technical one. Well, it might be a great concept, but it won't actually work technically. It's groundbreaking. It's using new technologies that have not been proved before. Is it going to work in real life? Is it going to break when it's released? Which, if you know, in technology, is the death knell of any new product. It might look good, it might sound good. If it doesn't actually work on day one, no one's going to use it. And in the age of social media, everyone's going to know about it. And then lastly, the risks that I think that people tend to think the most about in project management: schedule. Will it be on time? In some ways, that's actually less important than the other two, but it's the one we often focus on. So Agile development and the Agile methodology and the Agile manifesto really actually help with all three of these. And that's why I wanted to talk about Agile at the beginning, because Agile was actually developed, whether consciously or not, with reducing these three risks. So the first thing we do with Agile is we deliver small increments, we get feedback, we work with the customers interactively. We don't spend a lot of time writing things down before they see something. So we talk to a customer, write a story, define a requirement with them. 2 weeks later, they can see something in a sprint. We can show it to them and they can say, oh yeah, this is what I want. They can show it to a customer. Oh yeah, this will be useful. That's really useful in reducing conceptual risk. The technical risk in Agile, if you read the manifesto and what we're supposed to be doing, though we don't always do, we should be doing what's called spike solutions, which is find the 3 or 4 most technically risky parts. And again, going back to the brainstorming idea, we could brainstorm what are the most technical risks in a project at the beginning. What are we worried about? We're using a new NoSQL database. We've never used it before. Will it perform? We're using a new user interface framework. We've never used it before. Is it going to work on all the mobile devices? Is it responsive? ... Whatever risks you have, you should try those out early. Don't wait to the end. So you're proving out the technical and conceptual risk by doing those things early and showing it to customers early. And then lastly, because you are releasing in small increments, if 6 months the way through there's a change in direction, you've still delivered 50% of the application already. So you're getting functionality all the time. You're going to market faster. So that way you're able to adjust scope, adjust to changes in the schedule. And you can even put more people on the team, take people off the team as needed to adjust. So Agile is a really good way of addressing all 3 of these kinds of most common software project risks. However, it is a team job. It isn't just the project manager's job. It's the developers, it's the scrum master. Everyone on the team has to understand this: the what, the why, the how, the when, and they need to work together. Now, be careful though. Just because you say you're doing Agile is not a panacea. Just because we're doing that. So one of the challenges, people will say, we're Agile, great. We haven't got to worry about these things. Agile is going to fix everything for us. That's a very dangerous statement. Be really careful about that. Because one of the things we found is when you look at Agile, everyone thinks we're doing 2-week sprints, we're releasing functionality, we're showing it to the clients, and they're going to see this functionality. Therefore, we're done. Everything's going to be easy. We don't have to worry about this, because any risk that happens, in 2 weeks, we're going to have dealt with it. So they're focusing a lot on schedule risk, which is the risk of we don't have enough time for testing, we don't have enough time for development, which is usually what's happened in a traditional project. And because you're doing Agile, testing is effectively baked into the project plan because you have it in each sprint. It's not waiting to the end. So you're not running with the issue of compressing the project timeline, not having enough time for testing, taking shortcuts with the development, which is what used to happen. So certainly Agile does reduce a lot of schedule risks in of itself, but it's not the only thing. To mitigate the conceptual and technical risks, you have to be very intentional. It's very easy to go and to get a whole bunch of user stories from your customer. So let's say you're going to release a new application for online banking, and you talk to the head of online banking or the head of marketing, and someone there writes out how it's going to work. You get 20, 30 user stories. You do it in an agile fashion. You release it every 2 weeks. They see it being developed. They look at it. They love it. It's great. It goes live. The first time a customer uses it, it's unusable. They hate it. So the problem there is you have to understand who's the concept for. If it's an internal business app, then maybe having the bank staff look at it was completely fine. But you need to make sure that the actual users are looking at it. So you need to get real feedback, and that might be from end users. It might be you have to put together screenshots. So one of the things about designing a system might be just create screenshots. Don't even release the first sprint is not even technical. It might be just designing HTML mockups that you show to bank users first. That would mitigate any conceptual risk because they could see this. They could pretend they're clicking through it. We used to draw stuff on paper, but you can use drawing tools, HTML markup tools, basically show, a sprint doesn't have to be working code. It could just be a working prototype, enough to show the end users what the risk is, what the system is. So that way you can verify that it's actually going to work. And so the user stories and epics that you develop in your plan should be intentionally created to reduce conceptual risk. If it's not the first version of an application, if it's just an update, obviously that's a lot less. You don't need to worry about the conceptual risk so much. You should still do user design and user testing, but it's not so dangerous than if it's a brand new app. Also, if it's an online banking app and there's 20 of these already, you're basically gonna have the same one as someone else, then the concept's been proved. If it's a brand new app that no one's seen before, that's when it's much harder. Same thing with technical risk. There's a tendency for developers to like to build stuff even when it's not needed. An example I would have here is that we were releasing a mobile app and we had to build some functionality, some screens that would do data entry, data viewing. And so one of the developers spent a lot of time building a data access framework, a logging framework. They had all these shared services, all this stuff that they thought would be really useful. But then when we actually tried to deploy it on the phone, we found it was too heavy. It wasn't nimble enough. It used too many resources. It was slow. And so you need to really think about what is the risk in the application. Is it the network? Is it the technology? Is it the user interface? Whatever, the risks, but make sure you actually plan to test those out, because developers will often make decisions based on what they've either done before, what they think will work best. Good intentions, but the problem is by the time you've developed functionality on that framework, it is a lot of cost to redo and refactor everything. So if you aren't sure about the platform you're using, if you're looking between using Node.js or Java or iOS, Android, or Electron app, whatever it is, whatever technology you're looking at, if you're not sure about something, plan a spike iteration to actually reduce the technical risk. Just because you're agile doesn't mean those are going to naturally happen. Be intentional. So technical risk is something that your technical team need to intentionally look to mitigate. Some examples of that I can think about. One is an example I was involved personally with. We were building an application that would run on laptops that would connect between different. It was actually for the U.S. Marine Corps. That was going to synchronize logistics information in the battlefield on tactical radios. And we built this whole thing, and it looked great in the classroom, it looked great in the lab. We took it out into the desert. In California, we didn't go into the real war zone, but we took it to California. They set up a radio network. We connected it all up, and it failed miserably right at the beginning. We hadn't really tested it on a tactical radio network. And you think that's to be the first thing we did. But the thing is, we didn't have access to one. We didn't plan for it. We just said, let's build it. It should work. We'll use this. We'll simulate it using a cell phone network, but it's not the same. And so that's a really good example where we really didn't account for technical risk, and we spent a lot of time redoing it in later sprints. The other one I would say is interesting is the iPhone. If you ever watch the original video of Steve Jobs launching the iPhone, it's very interesting. He doesn't launch the iPhone. He launches 3 new products: a phone, a mobile web browsing tool, and I think it's an app store, and a music player. He basically launches three separate devices, and as he's talking about each one separately, He then slowly starts to bring them together. And at the end of the launch, he suddenly says it's actually one device, it's the iPhone. And if you watch it, it's fascinating because what he's doing, he's taking the user on that journey to something that doesn't exist. It doesn't exist yet. The iPhone was a smartphone. We didn't have smartphones. No one knew what they were. Everyone had these mobile phones that had very limited browsers. They didn't have app stores. They were all physical keys. It was a completely new concept. And to try and explain to a customer, this is a smartphone. Why would you want it? He went through the use cases. He went through how you'd use each of these three devices. And then eventually you realize it was one amazing device. So there's a lot of conceptual risk in the iPhone that they tried to mitigate by trying to think through the concept and present it to people so they understood the concept. In that case, communication was a mitigation. Now, the other problem they had was technical risk. And this one they didn't fully mitigate was a lot of people looking at the iPhone were like, how's this going to work on the AT&T network it was launching on? It couldn't, and actually it couldn't day one. But what they knew was that AT&T was so vested in having an exclusive with them that they would upgrade the network. So the mitigation for the technical risk was not to make the phone use less network. It was to go exclusive with one carrier and work with that carrier to build the network up. Another example, actually, it's interesting on this one would be, this is a long, long time ago, when they released the Boeing 707, it had a problem. It didn't have big, powerful engines. It could only fly to certain large airports with large runways, and that was a problem. So a British company created a whole new airplane, the Vickers VC-10, and the whole generation of design of it was it'll land on short runways, as if the first jet that could land on short runways. So they were going to reduce the technical risk of the fact that you couldn't launch from a short runway with a jet at the time by making a newer plane, but it was more expensive. The problem was, what they didn't realize was, because everyone wanted the Boeing 707, they just lengthened the runways. So technical risk is interesting. Sometimes you have multiple mitigations. You might mitigate it by making the plane work better. You might mitigate it by changing the runways. So again, it's not always easy. Another idea is the lean startup. This is the whole toolkit for launching a business. Look at this, it's very interesting. One of the things they talk about in the lean startup is mitigating conceptual risk. What they do there is they say, before you release a new product, create a website for the fictitious product, put a screenshot of this non-existent product, put a sign up button that goes to a mailing list. If no one clicks on the button for this thing, then no one wants it, and don't do it. So before you spend hundreds of thousands of dollars building a product, see if there's a market for it. So the lean startup idea is very interesting because they're all about mitigating conceptual risk by mitigating it through effectively a fake or prototype experience to see if someone actually even wants it. And the last one I would say is Windows 8, the conceptual risk, where they didn't really mitigate it, where they released a laptop come tablet in one device. They didn't do good testing with it. They thought they could force users to adapt because they had such a high install base of Windows, and there was a rebellion. People started buying third-party start buttons. It was crazy. If you look back at Windows 8, it's a terrible product launch, and Windows 10 came about to basically save it. And Windows Vista had the other problem of technical risk, where they hadn't proved out the technical risk of it working with all the different printers and drivers. So Windows has a whole interesting history around software launches and technical and conceptual risk. Anyway, some good examples. Feel free to look at those. Another thing to think about nowadays, though, is compliance risks. So you've got software, you can mitigate technical risks, you can mitigate conceptual risk, and you can mitigate schedule risk. What about compliance? So compliance is interesting because one of the challenges we're seeing is that at the same time that everyone wants to release software faster, we're going to do continuous integration, continuous deployment, that's CI/CD. We're using agile methodologies like Scrum and Kanban or scaled agile to try and reduce the risk, as I mentioned. We're using things like DevOps to release the software faster and more reliably into production. And we're also dealing with the pandemic and distributed teams and remote working. Everyone's going to the cloud. That's great, you think. Software faster, better, cheaper. However, data privacy. What about safety? Boeing recently did release a plane that had flawed IT in it, the 737 MAX. They didn't do a good job of really understanding the software that was in that product and testing it. We've seen a lot of issues with healthcare systems, IT systems, financial systems, where you have to be compliant. Governments are no longer saying, you're a software company, we'll trust you'll do the right thing. Facebook, we trust your data privacy. Mr. Bank X, you're doing a data migration of your customers over the weekend. go ahead. If it doesn't work, it's your problem, not ours. Those days are over. Software is so integrated into our societies and into the fabric of everything around us that governments are getting much more concerned about software. From a cyber standpoint, if we're attacked by a cyber attack, it takes down major corporations. That's just like a declaration of war. So the blending between government and private industry is changing. Cyber and in general, all of the rules and the compliances around software development are becoming far more regulated. So I think we can expect these two things to happen at the same time. We want to release faster, more agile, but governments and businesses and industries are getting much more regulated. So how do we square this circle? This is really hard. So one of the things I think we have to think about as software professionals, IT professionals, is how do we have the genius of the and? The Genius of the And comes from the Built to Last book, which is a great book if you ever want to read it. And it's the idea of we can't sacrifice the things on the left to do the things on the right. So one of the things that as a challenge for us is how do we become more agile and modern, but at the same time, we're able to do things like risk management. We can make sure that when we release software, someone's verified it, someone signed off on it. The data is being kept in a secure fashion. We're following data privacy rules. We're not moving data between different countries that we're not allowed to. We've proved to regulators that we've actually designed the software in compliance with the requirements. Clients might want to deploy behind the firewall on premise. Maybe they want to go in the cloud. They may need both. So these are the challenges you're going to see from a compliance standpoint, from a risk management. We have to be able to understand the risks associated with all of these things. Unfortunately, in this talk, I don't have time to go through all of the ways we can deal with compliance and agile. That really is a separate talk all of its own. But just to bear in mind, there are a lot of risks now between being agile and dealing with compliance. And these are some of the factors you have to consider. And then the other piece I would say around risks is hardware projects. We talked about software, but there's also hardware too. In a hardware project, we also have to worry about a third factor, which is called detectability. So one of the things to bear in mind is when you're doing risk management, also make sure not only are you looking at probability and impact, you will also have to look at what's called detectability. How easy is it to see the risk? Because if the risk is hard to see, there's a more likelihood it could occur. So one thing to think about if you're working in the hardware space, there's a thing called FMEA, and that's basically a methodology for adapting risk management to understand how you can do it in a hardware environment where detecting it is not a trivial matter. In software, it's easy to see things. In hardware, it's not. And then you have these three factors when you multiply together, and you get what's called a risk probability number, which is basically an extension of the exposure method we had before. So that's some of the risks in hardware. So just to recap, risks in software. In hardware, you have to adapt it with FMEA, which is a whole methodology which adapts risk management for use in hardware systems. Again, to take my earlier tack, doing it is great. Make sure you integrate your FMEA process into your overall project planning and project management. Okay, the next thing is software testing. So we talked a lot about project management, a lot about software development. What about testing? So there is a discipline that's now evolving called risk-based testing. Risk-based testing is the idea that, well, first of all, testing is a way of managing technical risk anyway. If you have risks and you're not sure how likely they are, one way to find out how likely they are is to test for them. If they happen or don't happen, or they happen sometimes, you can get a measure. But in general, testing itself can be improved by using risk-based approaches. Because the problem, as you all know in testing, is there's never enough time. So as someone says here, how much testing time do we have? Well, we're confident, but there's never really enough. And how much testing should be done with the time that we have? We only have, in a 2-week sprint, we have a certain amount of time. We have a certain number of testers. Developers will do some testing. Other people who are not the developers should do some of the other testing. That's a good practice. How much time do we have? With the time we have, what tests should we run? And how can we reduce risk with the time that we have? So rather than just picking tests randomly or running the test we ran the last time, or running the test that linked to the features we did, which are all good reasons, we can also try and think from a risk-based approach. So risk-based testing is the idea of taking all of those risks that we have. Here's the risks on the left. We've taken the probability and the impact. We've calculated the exposure, and then explicitly creating tests that map to the exposure. So if we can do certain tests that will test the release is not ready, or the system will not comply with PCI, just some of the things you see on the left. So explicitly looking at the risks that we have and tying those to the tests, or looking at the requirements in the tests and tying them together, we can come up with a number of tests that if we just did these 10 tests, these will reduce the overall risk in the system. And it looks something like this, where you take all the risks, you map them to the test cases, find out which tests cover the risks, put it together, and then if you look at this example, if I ran test case 1, 5, and 8, according to this at the very least, I would actually cover the most risks with 3 test cases. So if I only have time to do 3 tests, I should do 1, 5, and 8, as opposed to just randomly picking them. So that kind of thing, where you're using the data you have in your system to determine what you should be testing. And then another piece I want to mention is risk in cybersecurity. So development, testing. Another piece, of course, is cybersecurity. What we recommend and what we've done here, this is actually an example from our own internal dashboard. We went through, every year we send one of our cyber guys to DEF CON to find out what's the latest threats that we're going to see. And we basically come up with a risk assessment using the exact same matrix I showed you, the probability, the impact, and the exposure. And we're looking at all the risks that we have from ransomware attack, phishing, supply chain, physical device, etc., all the things. And we rank them for how likely they are, how impactful it would be to the company. And then we actually build out explicit mitigations from those that go into our project plan. Some of those might be software things that will go into our project plan for our software projects. For example, it might be that we need to change the password system in the tool, upgrade an algorithm we're using for encryption. It might be something that goes into one of our IT projects. It might be that we're going to be upgrading the device management tools that we're doing. So whatever it is that comes out of this, the mitigations and the actions will cut across the entire organization into our different parts of the company. But we start here. We start with the risks, and then we drill it down. Because otherwise, you could be fixing a security hole that someone's identified that's very, very minor, and instead there's this gaping hole that's the most likely thing you're going to face that you've completely ignored. So doing a risk-based approach makes sure you're really mitigating the most serious risks with the least effort effectively. Now, one thing that people have asked, I wrote a paper on this, was how is machine learning and AI going to change things? Is it going to change anything? It's interesting that. Who's going to check the machines? So AI will affect things in many different ways, and there's a lot of different pieces to this. And this is another talk that could be its own talk. So I can only touch on it here. But one of the benefits of AI will be, if it's done right, is it can avoid bias. One of the problems of risk management will be if you take a bunch of people and you put them into a room and you say, let's think of all the risks on this project or this system. What you're going to do is think about the things that have happened before. So you're going to probably overestimate the things that have happened before, and the things that haven't happened, you'll say, well, that's never happened before, probably isn't going to happen. That's hindsight bias. Everyone in the room works in the same company. You've got some of the same culture and skills. There's a danger of confirmation bias. Well, he thinks that's going to happen. I agree too. It must be a high priority. It must be really likely. The danger is someone's going to disagree, but not feel they can disagree publicly. Now, there are ways to get around that with anonymous voting and stuff, but it's not perfect. There's also the danger that things that are very unlikely, you may not even know about. So there may be zero-day risks that we haven't thought about because they've never ever happened before. How do you think of a risk you don't know about? That's very hard. So AI can help with some of these things because AI can mine large data. It can mine data from your internal organization. It can mine data from the industry. You could potentially use it to find risks that either you've never seen before. It could also take risks that you have identified, number 2, and come up with better measures of how likely or how impactful, severe they are. It might say, well, you say this is very unlikely, but we've done a big data model, and based on the industry, it's very likely that lightning hits data centers. It happens every week. Did you know that? Look at the weather. We mine the weather channel. We mine the electric utility, etc. Whatever it is. Big to AI and machine learning can definitely take out the human element and the biases and the assumptions and the gut feel, which can be dangerous in risk management because we're not always right. However, so that's good. On the flip side, AI introduces a whole bunch of new risks because basically you've now got a system that we didn't write. So, traditionally in software, define requirements, write code, test it, release it, life is good. AI is very different. AI is, let's get some data. Let's let the agents look at the data. Let's look at this tool, look at the data and come up with how it's going to solve the problem in a non-deterministic way. We don't know what it decided. It seems to work. Great. But do we know it handles all edge cases? Like self-driving cars, we we get these models from cars, we put telemetry on actual cars, we feed it into a model, we can build an autopilot. The question is, will that autopilot deal with different road conditions? Do we know what it was exposed to? Was it, they did a test in Pittsburgh for, I think it was was it Waze? One of the companies that was doing it. And Pittsburgh has that thing where you turn left on a red, one car can go through, no one else does that. It's called the Pittsburgh left turn. I mean, imagine that it learned that, and suddenly it's going to every other city where that doesn't exist, or it learns in New York City where you can't turn right on red, or whenever there's unique conditions, we don't know what biases have been intrinsically built into this model, and there are now risks that we don't even know to understand. So how do we test this? How do we test or validate an AI model when we don't even know what the requirements truly are? We don't know how it was written. So one idea we have around that would be, there are two ways of thinking about it, and maybe they're connected. Would be, if you have on the left this AI generated risk model, we've built this model, we've signed the impacts and the probabilities, have a human team red team it. So if we're going to have the computers decide what risks exist and what mitigations and things it thinks exist, have a human team do the exact same thing and then check them together. Or you could even have two. You could have in theory, you could have a self-learning application that's learned, or it's learned how to build this self-driving technology by itself, and we've air-gapped a completely separate AI tool that's checking it by monitoring its driving habits, but it has no input into the original model. So having one computer system check the other, and as long as they're isolated, and maybe a third feature will be a human team that's doing the same thing. So again, this is a larger conversation, a much bigger talk, but certainly AI machine learning will increase risks, decrease risks, depending on how you use them, but you have to be intentional. You can't just take a computer system built by an AI and release it into the world unchecked. In the same way that not using AI to look at your risk management methodology is foolish too, because then you're going to only be keeping human bias in the system. So you need to use AI, you need to use machine learning, but you need to understand the limits of it, understand where it can help and what risk it adds to the overall equation. So just to sort of wrap up in the final few minutes, first thing I'd like to state is, regardless of your role, risk management is for you. It's not someone else's job. One of the things I think that people often think about is there's a risk management team, they've got these spreadsheets, they do all this stuff, they come in and talk to us all, they take all our risks and they go off into an ivory tower and they worry about what we're doing. Risk management is your job too. If you're a developer, risk management is your job. If you're a project manager, tester, infrastructure, IT person, DevOps engineer, whatever it is, it's part of your core discipline, or it should be. Understand how you can mitigate and understand risks in your system. Make sure that risk management is fully integrated day to day into your project plan, into your process. Again, it can take baby steps, not all at once. And then think about how you can use risk management in your different disciplines. Now, we use it in development, we use it in testing. We recently started doing it in cybersecurity, which has been really useful. And then we're bringing it all together into our other projects. So we find it's a really important tool that should be used in all aspects of an IT industry, IT organization. And then in terms of AI machine learning, they do have the ability to radically change things. They can make things much better. They can make things worse. We have to be intentional about how we're going to use them. They can help risk management discipline. They can also make our software applications unpredictable and erratic if we don't understand how the data was used, how the models were built, what biases exist in them, and what edge conditions they have or haven't been exposed to. So with that, just want to acknowledge Dr. Sriram Rajagopalan. He is a member of the leadership program faculty member. He's also worked in Inflectra as our enterprise agile evangelist. And during the creation of this presentation, I bounced a lot of ideas off of him. He was very instrumental in helping me validate some of the things I want to talk about today. So I just want to give a shout out to him and all the help that he has given me on this presentation. And with that, I would like to hand it over to questions.
Thank you very much, Adam. And I really enjoyed your presentation, and I'm sure all attendees really learned a lot about the application of Agile in software development and mitigating risks. And surprisingly, my experience, not all small or medium scale companies take risk management as serious as scope, schedule, and cost management, especially those thinking that working on a project that they did kind of similar before, and they think
Right.
since we've done it before, so we can do it again, but not really consider important aspects of requirement management, connect with clients to actually understand the conceptual framework when we talk about new projects. And you beautifully explained and categorized the main considerations under conceptual, technical, and schedule. When you explained it, I thought of what about compliance policies and cybersecurity? And then later in your presentation, you touched on those important considerations in risk management as well. So we have a number
Thank
of
you.
questions.
Go ahead.
Yep. Let's ask, we have talked throughout the symposium about the many leadership styles that must support organizational success. And is there any particular style that best support organizational leaders in their understanding and control of risk management? In Randy, our presenters who presented yesterday, responded that probably, influential leaders are ones who speaks risks terminology and ask questions of project team about their risk plan. What do you think?
It's a great question, and I'll give it. One of the experiences. This was actually on the project the Untethered project for the Marine Corps that we did. One great piece of advice I was given. I was one of the project managers with a colleague, and one of our reviewers of the project said, "You're doing something very high risk here, and we haven't done it before." And as I mentioned, we didn't even get it right when we tried. But what they said is, find the person on the team who is your biggest pessimist and listen to them. So as a leader, one of the things they said is the danger is if you've got you have a strong charismatic personality, you're versed in risk management, you will put people off expressing things that they might be worried about because they'll feel like they're a naysayer. And in our culture of software development, I don't think we like naysayers. We're going to get it done. We're going to muscle through. In 2 weeks, the sprint's going to be done. There's a bit of macho heroism here, and that's a big danger. So I think as a leader, you know your personality, you know your strengths and weaknesses. You should know thyself, but you should therefore make sure, if I'm the kind of person that people are not going to publicly want to talk to about it because they're afraid, go find people in private one-on-one, ask them. So I think as a leader, you need people to be able to speak up without fear of retribution, without fear of looking stupid, without fear of looking bad to their colleagues. And so you need to make sure that you know how you are, you know how people relate to you. Make sure you find ways to mitigate that so that you are open to people giving you the actual hard truth. Because what they're worried about is going to be the things that you should be worried about. And if you're not worried about in 6 months, you will be worried about when it's too late.
Absolutely. Karen asked, in my mind, some of the biggest risk facing projects these days are within the globality of many projects. And geopolitical unrest, disrupted supply chain, pandemic, etc., are all considerations that we need to take into account. What are your thoughts?
Well, definitely. One of the things that with the pandemic is sort of everyone has started working from home or other places and these digital nomads. And then you have war going on at the same time, people have been fleeing their homes. And without going into too much into the geopolitics side, we have customers in the Ukraine. We've got customers where we've had support tickets come in, people working from their basements under candlelight with network connectivity still working. It's amazing how people are still able to work under these conditions. But as organizations, you have to think about where is your software developed? What are the risks for that? If you're building software in, say, China, Russia, companies do that. What are the mitigations for that? If you're building software in Europe versus North America with a GDPR, I think the days where people can simply have developers everywhere and we're all working together is unfortunately maybe not as easy as it was. We're seeing a little bit of a rollback in globalization. The US wants to put chip making back in the US from a national security standpoint. Are we going to start seeing the US saying we want some developers to be in the US, some testers? I don't know. I mean, these are controversial geopolitical questions, but as companies, we shouldn't put our head in the sand and say, oh, we're going to hire people everywhere and the government can take a hike. I think the real world, the 1999 internet optimism is hitting 2022 realism. We as industry leaders have to be at least aware of this and think about it and think of these risks. Again, what are the risks of a government saying that any project in telecommunications has to have US developers? Imagine that went into law overnight. What would that do to all of our telecommunications companies and all the fact all the base stations are made outside the US? I mean, it's interesting, but yes, big questions.
Great. And also we have some discussion in the chat box regarding the responsibility and who bears the responsibility of dealing with these higher level of risk as your answer, the organization or the project manager or team?
I think, well, I mean, I think it is a shared risk. I mean, I wouldn't expect a team to deal with the fact that we've got a national security law coming out. By the way, it isn't coming out. I'm just saying if it came out, don't get worried, everyone. But if a law came out that required something, it's not fair to expect the team to deal with that on their own. On the other hand, the organization leadership would be set the framework and would meet with the teams and say, based on what we're seeing these new policies and compliances coming out. Maybe it's just GDPR, something simple like that. And then we go to the teams and work with them to understand if GDPR is going to affect us, how does this system have to adapt? So I feel like there's degrees of shared responsibility. Organization sets the tone, organization makes it a priority, works with the project leadership to understand what are the impacts and the mitigations on that particular system, what are the costs. Then the organization has to pay for it. The organization has to invest. Because what we don't want happening is the teams feeling like they're being forced to do all their current work and they're being given all this extra work and no one's investing intentionally in it. So the organization has to basically decide, if we're going to do this compliance stuff, what are we giving up? Because nothing's for free. If we're going to do this, we're going to separate the databases out for US and Europe because we have to by law. What features are we not going to deliver this year? There has to be a trade-off and it has to be intentional, and it probably has to come top down. So I think the responsibility is shared depending on the kinds of decisions we're talking about.
Absolutely. And also we have one comment from Randy saying that I think Jeffrey Moore cautions project managers to pay attention to market forces and technology adaptation life cycle. What do you think about it in consideration in risk assessment?
He cautions it, meaning they should be doing it. Is that's what he means?
Yeah.
Oh, for sure. I mean, certainly you have to be aware of what's going on in the market. I mean, look on Bloomberg every day. Look at the valuations. And I think I was talking to someone from Silicon Valley yesterday. He was saying that, oh yeah, they'll give $1 million to anything with a pulse last year. This year, not so much. So, that's obviously a simplistic example. But I think no, as a developer, as a project manager, as a leader in an organization, you got to look at the market, because if you're not doing that, you're flying a boat, you're sailing a ship into a storm without knowing whether you should be battening the hatches down, what preparations you should have on board. No, you have to look at market forces. You have to look at the economics. Look at the energy crisis going on in Europe right now. We as a company are worried about that. How's that going to affect our customers? We have customers in the energy industry. And the dollar is really strong right now. Those two things are causing major disruptions to us, because we have customers in Europe paying in euros. We charge, and we charge in dollars. We have customers that need to use energy. They got more costs next year. How does that affect our pricing? Does it affect the fact that they won't be able to use our software? I mean, GDPR had a massive effect on us. So I think putting your head in the sand and saying doesn't affect us is not going to work.
Great. And we have Dr. Jacques Alexis, risk management expert, with us. Your thoughts? Do you have any questions?
Oh, sorry, I did post something in the chat, but I certainly can ask. This is a fantastic presentation, very accurate and relevant to what we're talking about. We were talking about this morning, business resilience, and made the point. So my question was, well, actually I have two questions. The first one, from your experience, do project managers pay attention to market risk, or do they focus more on project risk, such as technical risk and schedule and cost?
In my experience, unfortunately, it's the latter. They spend more time on internal project concept, project risk, schedule, cost, team. I just feel like that's where they tend to overly focus. I feel like traditionally they haven't spent as much time on market. The product owner and maybe the customer stakeholders, they will think much more about that. But certainly the one thing with Agile, we kind of split this project manager into the Scrum Master and the product owner. Product owners are thinking a bit more outward. They're thinking of the features and is it going to be used? Who's going to use it? The Scrum Master is thinking of team, schedule, cost. So the question, so I think project managers become sort of this bifurcated, two-hatted monster sometimes. So unfortunately, I think teams do look too much inward. And I think what the world is now showing us that they need to look more outward than they have done.
Absolutely. This makes perfect sense because, in organizations, we have division of labor, right? So some risk may be managed at the portfolio level where, project managers focus on delivering the project on time, on budget. certainly make
the
perfect
problem, I
sense.
think, is that the danger will be is that there might be a market risk that's only going to, that someone on the team will understand the impact that someone on the in the high levels might miss. So there's that danger of specialization at times where perhaps, for example, GDPR came out, someone working on the DBA team suddenly realizes our primary key is someone's personal social security number or is their email address, which would be terrible because GDPR would say that can't be a mandatory field. And a DBA would know that. A program manager will be thinking about it, but only a DBA would know it. And then it gets missed. So that's the danger of specialization, is you can sometimes miss these intricacies.
Absolutely. And there is also always the possibility of escalation. So I decide this bit. It's not my job to manage it. So I'm going to pass it over to someone else who can actually do it. Now, the other question is, what is the software applications you're using for risk management?
Okay, I mean, we don't generally talk about this. Is an industry talk, not a product talk. I've used some screenshots from our products. The tool is called Plan, but again, this talk's not about that. And in the interest of being a objective, I shouldn't talk about the product too much. So, but the tool we use is our own tool that we sell in the market called Plan, and I'm happy to talk offline about it. Yeah.
Oh, I see. Yeah, interesting. Thank you very much. Great presentations here.
Thank you. Any other questions? If not, I have one comment that came to mind about you mentioned about making a system that's like another system. I remember a story from my early days at Sapient. I wasn't on the project, but my colleague who was actually on the Marine Corps project with me, it was his horror story. The company, and it's a long time ago, so Sapient probably doesn't mind me mentioning it, and I won't mention the clients. We had a company we had a bakery in one city that had Sapient build an automated bakery product that was to basically print labels on their baked goods, and they built it and it worked perfectly. Great. So then the second supermarket in a different part of the country came to them and said, can we build the same thing for us? And Sapient said, oh, we've done this already. Great, we can underbid everyone else. So they underbid everyone else, and because it's the same system. They didn't read the spec carefully. There was a performance requirement that was much tougher than the first supermarket. Like it had to be a label had to be printed in 1 second from the point you entered it on the terminal, and the one for the other one had no such requirement, and the system couldn't do that. They ended up having to rebuild the entire system from scratch. It took a whole extra year and millions of dollars, and it was a fixed price contract because they did that because they knew what they were doing. And that's a huge example where you have one pattern in your mind and you do pattern matching, you think it's exactly the same, and a huge risk. Anyway, so it's a really good example you gave about that. That's a big danger we have. It's that hindsight sort of confirmation bias of we've done this before. We know the pattern.
Great, thank you very much. I was checking the chat box. It's still very interesting conversation between Kevin and Sriram about the responsibility in organization regarding risk management, the authority of project managers dealing with risks. We do not have more questions. So again, thank you very much, Adam, for attending and also the great presentation and answering all questions. And it was a pleasure to have you with us.
Thank you very much. It's a pleasure. I'd love to come back anytime, talk about any topic, and maybe we'll do it in person. That'd be great. So have a great rest of the conference, everyone. Thanks so much for listening and great questions, and enjoy the rest of the Friday events.
Thank you very much. And
thank you
all attendees for attending this session. And we will be back at 11:30 with the next presentation. Thank you all.
Thank you, Adam. That was that really was excellent, and I no hyperbole, no exaggeration here. I'm very serious. You just had me going with some of the examples, especially. I love it. And the Marine Corps example was especially one that I could easily relate to.
Yeah, there were SINGARS radios there were SINGARS and EPLAs, if you know them.
Let me tell you now. I'm dating myself, and I hate to do that, even though it's a reality check. But in the let's see,